All right. This is our 64th lesson on the biblical flood. And we're getting close to the end of the book, but we're got a few more lessons to go. We're going to look at correlation and cause and effect. Now, when I was taking some graduate courses and doing research, scientific research, one of the things we learned right quick was that a lot of people have a problem in thinking if two things correlate, they automatically cause an effect. All right. Let me illustrate this. I know a preacher friend of mine whose wife she's 93 years old, and good, godly woman. Her husband, a preacher friend of mine, he died a few years ago. And her birthday is on August the 20th. That happens to be my birthday. Now, if we were twins, the likelihood is real strong that we'd have the same birthday. Does that mean just because we have the same birthday, does that mean that she and I are twins? Not hardly. I'm only 79. I'm not 93 like her. Well, there's another man that went to the congregation where her husband and I both preached together, worked together. And he was born also on August 20th, but he's 10 years older than me. And he just passed away just recently. So he and she, all three had the same birthday. And of course, if we were twins, the likelihood is real high that we'd have the same birthday, although I know of some twins that have different birthdays. So here now, just because we have the same birthdays doesn't mean that we're twins. So there's a correlation, there's a cause, and there's a relationship, but not necessarily a causal relationship. It just happens to be the case. There might be something else that caused it to occur. All right. So we'll go and illustrate some other things to show correlation doesn't always mean cause and effect. That's a mistake. It's a logical fallacy, actually, to think it does. So this is one of the problems we see in scientific research. They argue from correlation and they think they've proven a cause and effect. That's a serious error to make. Okay. Let's go further. We'll look at correlation in what's called VARVs. We'll define what a VARV is later. Then we also have a correlation in VARVs. And let's look at correlation used by statisticians to test scientific hypotheses. And we'll look at a method used by scientists. I believe it's strange to most people, to what I would call laymen, but by that I mean non-science people that aren't trained in scientific training, that they find it kind of strange. Correlation is necessary for a cause and effect, but it doesn't prove it. A lack of correlation will prove there is no cause and effect, but a presence of it could have been caused by something else. Now, we will show some illustrations of this later, but so they attack it from a negative standpoint. If they don't find a correlation, then they automatically assume there's no cause and effect. But that doesn't, the presence of it doesn't prove there's a cause and effect. And you have to think that through, and we'll try to illustrate it enough that you can see the difference. Right? The scientist will attempt to disprove the hypothesis. It's called a null hypothesis. And if he fails to disprove it, he has not proven the converse. You have to keep that in mind. So what I'm saying is, you'll try to disprove something. You'll say, if this is true, then this should be true. But he says, this is not true, therefore my premise is not true. Right? If little green men okay, I'll illustrate it with something else later. Okay. ROP This is the famous atheist. He says that geology and paleontology is the study of fossils, and that's a branch of geology, are historical sciences. Now, remember, we've argued and shown that true science has to verify it by the empirical method. It has to actually see it. If they can't see it, it's not science. And what they're doing is they're making arguments from historical method. It's historical. And it's by the same definition that we get faith. They're basing it upon evidence. They're making arguments from evidence. And so he says, Ropp says geology and paleontology are historical sciences, and that these sciences rely largely on statistical inference. They draw an inference. Now, what we run into is the logical reasoning or lack of logic on the part of most atheists is amazing. They commit logical fallacies. We'll show you one of the logical fallacies of the atheist in the reasoning from correlation and cause and effect. Some atheists have wrongly thought that coincidence of actions prove a cause and effect. Doesn't necessarily prove the case at all. We'll see that. Correlation does not prove cause and effect. Correlation is necessary for the be cause effect, but it won't prove it. Okay. Now, let me illustrate this. If I killed President Kennedy, hypothetically, then I had to be in Dallas, Texas in November, on the date in 1963 when he was killed. Would that not be true? Everyone agree. Now then, if that's true, then the fact that I was in, which I wasn't, hypothetically, suppose I had been there at that date, then that wouldn't necessarily prove it was necessary for me to be there to murder him. But the fact that there were 1 million people or more that were in Dallas, Texas on that date doesn't mean that all those people killed him. You had to be there for him to be killed, to be the killer of him, the murderer. So we have to be careful how we reason. And so correlation and cause effect. Now we're looking at just statistical correlation, and it's a little different. So let's look at it more thoroughly now. Science is ultimately concerned with identifying cause and effect relationships. Well, that's good and right. Since such relationships are always correlated, see, a cause and effect is correlated, but correlation, you can't reverse it and say you have a correlation, therefore it's a cause and effect. Now, this book tells us, since such relationships are always correlated, there's a strong tendency to reverse the process and infer cause and effect status because two or more variables based on the established correlation coefficient. He tells us there's a strong tendency to reverse the process. The danger is clear. Correlation does not necessarily imply causation. He's going to illustrate it here. Two variables simply may be correlated with a third variable, as in the case of a positive correlation between water temperature and the incidence of drowning along the coast of California. Now, so he says, the water temperature, there's a correlation. The warmer the water, more people drown. Well, it might be that the water is too cold, nobody goes swimming. It may not be the temperature of the water at all. It's the water is incorrect, concluded that the warm ocean water is more dangerous. And the explanation lies in the obvious fact that more people go swimming when the water is warm, and activity increasing the exposure factor. Isaac and Michael, this is a scientific research handbook that I took when I was working on my doctorate degree. So right here, he tells you something that's obvious. And you could go to shark bites. People are attacked by sharks. Well, the people have to be in the water to be attacked by sharks. And so if it's real cold water, they might not be in the water, okay, to be attacked by them. So you have to be careful what you assume about stuff. Correlation didn't prove cause and effect here. The warmer water was more drownings. That proved the warmer water caused the drownings. All right. The correlation of a decrease in oxygen. Now, here's the things that correlated, and I believe correlated with the flood. Correlation decrease in oxygen content. We proved that in our studies, and this was scientific evidence from matter that they have discovered in the atmosphere, from about 35% to down to about 21 present oxygen content. Barometric pressure atmosphere from about, right now it's called 1 atmosphere, it's about 14.9 pounds per square inch of pressure, roughly 15 pounds of pressure per square inch. And the pressure was about, there's evidence that it was probably 2.5 times that prior to the flood. And so the barometric pressure being greater, the deposition of sediment, the extinction of organisms, apparent reversal of the Earth's magnetic field, and all these other things we've been studying are only coincident actions brought about by the same phenomenon, not the cause of the ice age or the mountain raising, orogenesis, and so forth. So these are coincident actions. They're coincidental actions. Now, we can say they happened at the same time. Maybe the same thing brought all of these upon, or a series of incidents that were all linked together, brought it on. Correlation is a necessary condition for cause and effect. In other words, you can't have cause and effect without correlation, but you can have correlation without cause and effect. So it's not sufficient. Here's another source, and again, another research handbook that I had. In interpreting correlation, one caution is imperative. When you find evidence for the existence of a relationship, you've not found evidence that one factor caused the other, right? In many cases, both factors themselves caused, but yet a third variable. One of the things that I learned in doing research, I've had 18 semester hours of statistics, and we did research courses as well. And one of the things I learned right quick was sometimes you had to test with a system that would try to link out or null out or get rid of other variables in a good research project. So there might be something else causing the situation. So in many cases, both factors are caused by yet a third variable. And he skips down and says, in general, causative statements are inappropriate in the interpretation of correlations and should be avoided. So you don't argue causative statements when you get a correlation. So you should avoid that. It's one of the things we learned right quick, to avoid that. Should be remembered that a lack of correlation can disprove a cause and effect, but the presence cannot conclusively establish a cause and effect. So that you can't reverse it. There's a positive correlation between the crime rate in the United States and the salaries of most occupations, because the crime rate has gone up in the past few years, and the salaries have gone up at the same time. So whatever your occupation happens to be, I can argue, well, that caused the crime rate to go up. Well, it didn't necessarily. It may have, but it would be kind of ludicrous to claim it did. So there's a correlation, but there's not a cause and effect. There may be some occupations that have caused an increase in crime, but most haven't. Okay. Who make the absurd claim that there's a cause and effect relationship between the salaries of most occupations and crime, that there's a correlation. Both of them increased during the same time frame. Right? This might be one of the uses of correlation to cross-match tree rings, as we've already studied tree rings, seems to prove the Earth is over 10,000 years old. But the usage of correlation to cross-match tree rings, we're going to show some problems with that, but also look at some other means of dating the Earth. Right. The tree ring widths and other factors used to cross-match the trees might correlate because of other factors. For instance, your tree rings, they'll take a tree that's 500 years old, and they'll take some of its rings and other tree that they know have come from lumber that was 500-600 years before that. They'll take something from a building or somewhere that they know when it was built, and maybe it was built 1,000 years ago, and they'll get wood from that region. Now they'll look at the tree rings and they'll cross match them, but they're not even from the same time frame, or they may overlap one another a little bit. So the rings will overlap. Now, we've already been through this before, but we have other problems with this. And why would they overlap? Why would they correlate? You say, well, there's correlation. Well, there would have to be correlation for these to be overlapping, to be linked. And so a factor that could make them overlap is there is an 11-year sunspot cycle, which could affect the width of the tree rings. Very simple. And so every 11 years, you're going to have a repetition of the sunspot cycles, right? You have other factors. In fact, this 11th-year sunspot cycle was what A.E. Douglas expected to find from his initial study of tree rings that he introduced, I think back in the 1950s, all right, 1901, begun in 1901. And A.E. Douglas in 1901 started this. That's a long time ago. That's over 100 years ago. The first extensive study of tree rings in the United States was begun in 1901 by the astronomer A.E. Douglas, who had hoped to correlate sunspots and climatic changes. So he wanted to look at the tree rings and see if he could correlate the sunspots with the tree rings. And his word led to the development of precise tree ring dating. But he was thinking it would be linked to the sunspot activity. That's the very beginning of it, to try to date stuff by it. Dendrochronology is called. If sunspots are periodic just means it repeats on a certain period or time interval. Some of the correlation found in tree rings might be from this periodicity, or the periodic nature of the sunspots. But sunspots aren't all there is to this. Levy and Lütgens claim that there's a correlation between sunspot activity and tree ring widths when they state that a comparison of recent radiocarbon fluctuations in tree rings with sunspot numbers since 1000 AD suggests that a correlation exists between them. Now, we've already talked about radiocarbon, but sunspots would tend to change the radiocarbon rate produced because of the amount of particles that produce it. Now, most of the radiocarbon is produced by neutrons, but some is produced by high-energy protons. And so what we have here is the more sunspot, the more of these particles you're going to get entering the upper atmosphere of the Earth and creating radiocarbon. So a low sunspot activity will have a lower radiocarbon production, and a higher will have a higher one. And so Libby and Lütgens claim that there's a correlation. Well, there could very easily be in the tree ring widths. And so what they have, there's a correlation exists between them, and it was the width of the tree rings and the radiocarbon in them as well. We have something else called barbs. We've talked about them briefly, but we're going to look at them in more detail tonight. We've already done the tree rings, and so we're not going to spend a lot more time on them. But remember what we had in our earlier study on that, they'll overlap tree rings and then project them backwards in time to get thousands of years. And we have what are called barbs. Now, a barb is a layer of sediment that's formed pretty much into a rock from one dry lake to another. They're overlapped and correlated to prove that glaciers took thousands of years to retreat off the land. And so the Earth has to be hundreds of thousands of years old just for the glaciers to retreat. Look at a varv in just a minute. It's derived from the Swedish word varv, which whose meaning and connotations include revolution in layers and cycle or circle. So we have a revolution, and a revolution, don't think of it as a revolution where there's a war going on, but that word is used for revolution. But the revolution is to revolve or to change. So we have revolution and layers and circle. So that's from the Swedish word. The term appeared in reference to varved clay on the first map produced by the Geologic Survey of Sweden in 1862. So again, that's varved clay, layers of clay. We'll have pictures of that in just a minute. Initially, a varv was used to describe the separate components of annual layers in glacial lake sediments. But at the 1910 Geologic Congress, the Swedish geologist Gerard de Geer, who died in 1943, proposed a new formal definition where varv described the whole of any annual sedimentary layer. Now notice, I want you to notice something about this. They're assuming these layers are annual. That is, they take a year to lay it. So that these layers were laid in 1 year. That's an assumption. They have the layer, they assume it was laid in 1 year. So they count 100 layers, they say that's 100 years. Or 1,000 layers, they say it's 1,000 years. And so they assume that they're annual layers. That's what their assumption is. Most recently introduced terms such as annually laminated are synonymous with the varv. Annually laminated layers, laminations. Now here's a picture of some varvs, and these are layers. Now the assumption is, and I'll pull my mouse over them, this white looking, lighter colored is one layer, and then this another layer, that these were laid in periods of time from the top of the white one to the bottom of this one to the top of the next white, lower, lighter colored one. I'll call it white. It's not actually white, it's kind of whitish color. The top of there to the next layer that's light colored, that would entail 1 year time. That's an assumption. That's an assumption. And the assumption is that it's just a pure assumption. So you need to be very careful about basing the arguments on assumptions. The coarse sandy layer is supposedly formed when there's a rapid water motion. So the coarse sandy layer is when there's a rapid motion. That's light colored. And the fine silt layer is supposedly formed when the lake is covered with ice. So here's the finer layer up here, the darker colored, right? So when it's covered with ice. So the lake, the water froze, thawed out, froze again, right? In addition to seasonal variation of sedimentary processes and deposition, varv formation requires the absence of bioturbation. Now that's a big fancy word. Bio is for life. Bios is the Greek word for life. Turbation is for biological organisms to stir up the bottom, to create turbulence as they bore into the bottom of it, to perhaps eat various organic matter that's in the sediment. And so it requires an absence of it. Consequently, varvs commonly form under anoxic conditions, that is, conditions where there's no oxygen, so that there won't be any biological organisms to cause turbation or to stir up the bottom. Problem. So we have we have the silt layer, that's your fine, and then there's your coarse, your sandy layer, this lighter colored. Okay. Picture. Here's the Scarborough Bluffs in Toronto, Canada. This is layers of varvs. That's what they look like. These are your layers. Now, they assume each of these layers took a year to lay down. That's their assumption. I believe it's just an assumption. They don't have any proof of it. It's a pure assumption. Shoreline of the present Lake Ontario, they're formed by glacial Lake Iroquois. And we've already talked about the Lake Iroquois. That was a glacial lake that was there and formed after the flood. The bluffs have been described as a geologic wonder and a unique feature in North America, these bluffs here. There's the Lake Iroquois, this whole region that's blue. And here's New York, Adirondack up layers. And there's Lake Albany, and this was all drained. There was a river across here draining this as the water melted, the ice melted, Laurentide ice sheet melted. And so this is your layers. Now here's our present lake that we have here now at this time. But this was all lake. We've been through this already before, so we're not going to spend more time on it. Right? Here, back here is the glacial Lake Missoula in Montana. Lake Missoula in Montana. I would love to go up there and see that. I've been to Montana several times, but I've never gone up and seen this stuff here. I want to go see it. And I'd like to do that next summer if the Lord wills. I'd like to go up there. But here's the bars, and these were obviously formed by glaciers or ice formed from glaciers, probably. Most likely was. Here's Lake Missoula. Here's the glacial Lake Missoula. And this broke. We've already been through that. And it had an ice dam here that broke. And there's evidence of this. This is a pretty good sized lake. Montana is a pretty big state. And it went out across and flooded this floodplain and had what's called the scablands. It stripped all the topsoil down to the bedrock. And so there's not much topsoil there in some places. But that lake drained very quickly. So we have that there as well. Now, how long that took? Was it thousands of years or just a few hundred years? The matching, did the waters take a year to lay one layer, or did the waters move back and forth as winds and wind currents move back and forth and create one layer after another over a period of maybe a few weeks? The matching of the relative thickness in barbs in lakes. So they look at the thickness of barbs in various lakes have the same drainage basin. And so they look at that. They look at the correlation of the laminae and believe that the correlated layers are synchronous. That is, they're synchronized in time. And it yields a record of the number of years the water stood in each. The duration, remember they've taken each layer as a year, stood in each, and the duration of each for relation to those to the south and the later lakes to the north. So they say the northern lakes were frozen over, and as the glacier retreated, the southern lakes and the northern lakes, there was a correlation. So they'll take a few hundred layers on the southern lakes, and they'll correlate them with the lake just a little bit further north of it, and they'll supposed to correlate the thickness of it. Well, that really doesn't prove anything. That does prove correlation. There'd have to be that for them to be linking these. So then they take this and link them and supposedly put all these wires together to get tens of thousands of years of time. Now, Kay and Colbert say about this, that because of the possibility of gaining all barbs in a single section, the total must be interpreted from a correlation of barbs in many sections. So what they do is they correlate it with barbs from various locations. Such correlations are difficult to demonstrate as precise. Now these are Kay and Colbert. They say they're difficult to demonstrate as precise. They're not precise. So they have been subject to criticism. In this way, it was judged that the ice took several thousand years to retreat northward from Long Island Sound to New England. So they make that assumption. And again, they assume each layer is a year. and then they overlap them with one another, and supposedly get there thousands of years. That's how they do it. They may only have 200 or 300 barbs in one lake, and then 200 or 300 barbs in the lake north of it, and then they'll overlap them. They'll overlap the in time, and they may get 190 years out of two 100-year sets of barbs, but they overlap them. Cloud claims there's a correlation between barbs and tree rings. He links them and claims there's a correlation. He says tree rings and barbs record Earth history year by sidereal year. Now, sidereal year is the time it takes it to go around the sun, and season by season. Indeed, such records can even be correlated by distinctive cyclic events from one continent to another. So he says we can correlate them from one continent to another continent. Right. Now, again, just because there's correlation doesn't mean there's cause and effect. The Bronze Age barbs of southern Russia, for instance, have been correlated with tree ring records in Turkey. Well, southern Russia and Turkey are not that far apart, and the bristlecone pine sequence of the western United States. So they correlated stuff that's going on in Russia with what's going on in Turkey and the country of Turkey, and in the United States, halfway around the world. Sonnet and Williams claim that there is correlation between sunspot activity, which is periodic, and barb thickness. But now, wait a second. The correlation might be due to sunspot activity. It might be due to something else. The bristlecone pine sequence, and the beauty of the bristlecone pine is they live several thousand years. And so they've supposedly linked those back, and that's their claim. And so they overlap them. We've been through that already in our studies earlier. Again, they're using correlation because the tree rings, the width of them correlate. There'll be a narrow ring and then a wider ring, and they'll overlap them and say, okay, we got 3 narrow rings in a row and 2 wide rings, so they overlap. Well, could that have happened in other places or other times? Yes, it could have. If these tree rings and barbs both are caused by sunspot activity, which is periodic every 11 years, or other activity. There's other factors. We're going to come bring some more up. In general, the barb spectrum qualitatively mimics that of the sunspot index. This is Sonnet and Williams. So if the sunspots repeat every 11 years, when you overlap them, you can just move them around and fit them in again and again in various places. If they're linked with the sunspot activity. That's what he says. It mimics the sunspot activity, which is about an 11-year cycle, roughly 11 years. But it's cyclic, it's periodic. Barb thickness is positively correlated with the sunspot index. As barb thickness and meteorological variables have previously been shown to be strongly correlated, a direct link between sunspot index and barb thickness is suggested by way of climate response to solar variations. In other words, with the 11-year sunspot cycle, you could overlap them. Let's say we got 100 barbs in 2 different layers in 2 different lakes, and you could fit those together about every 11 years. You could fit them. And so you could correlate it pretty easily. You could slide it around and fit it just about anywhere if it's correlated with that 11-year sunspot cycle. The correlation of barbs with different lakes to attempt to project backwards in a time of the series, the southern lakes at supposedly one time frame, and then the lakes further north supposedly overlapping with the later times of the southern lakes. The correlation of barbs from different lakes to attempt to project backwards in time of a series of barbs overlapping them to go back many thousand years contains a possible error. It's possible correlation based on the sunspots, which is a 11-year cycle. And so they would fit together in different locations rather than the other factors. So what do they do? What do? They bring this in, and they'll use radiocarbon and other factors to date it as well. So we come back to radiometric dating when it's all said and done. Perkins and Sims did not find a correlation between the mean, which mean is the mathematician's word for average annual temperature, outside the region of the lake where the bars were found. So he didn't find a correlation between the mean annual temperature outside the region of the lake where the bars were found. So if you go to other parts of the world or even other parts of the nation, you can't correlate what he says for the same temperature range. Clearly, there's no evidence, Perkins and Sims tells us, of any strong regional correlation between bar thickness and the mean annual temperature of locations far removed from Alaska. So he's taken the bars in Alaska and trying to correlate them with the mean average temperature, annual temperature, in other locations like Siberia and other places like that, in Russia and in Europe and so forth. And he can't find the correlation. Well, if there's no correlation, there's no linkage. There has to be correlation to be linkage. That's the problem. It's evidence that the correlation of bars in lakes far removed from each other might just be the correlation not of the bar, but of the sunspot cycle, or something else rather than any other factor. There are other factors besides sunspot cycles that would cause these bars to have different levels of thicknesses, even if they're annual layers, which I don't think they've proven they're annual layers to begin with. Since the sunspot cycle appears to be periodic, and the best we can tell it is, these bars cannot be overlapped projected back in time with a degree of certainty. Because you could, if they're periodic and they follow the sunspot cycle, you could slide the layers around at different places and link them together, different time intervals. Two other factors might cause the correlation of bar thickness and tree ring thickness. We have the first factor. There's a 100-year thunderstorm cycle discussed by Levy and Lukens, page 5902. And again, I cite these books and these articles in my book. So we have those. We have the El Nino and La Nina effects. The El Nino and La Nina are kind of the opposite of each other. One of them is the water heats up in the South Pacific, in the Pacific Ocean, and the other one, the water cools off. These cycles go one right after the other. They alternate back and forth. I'm not even sure they know what causes the El Nino, La Nina effect. There's evidence of El Nino thousands of years ago. There's evidence of La Nina, El Nino. If you go in and do a research, just Google those El Nino, you'll find a bunch of articles discussing it and going back thousands of years to evidence for it. Back in the days of the Roman Empire, the El Nino effect existed. There's evidence of it. So El Nino is not being caused by automobiles because it was going on 2,000 years ago. And so again, the global warming stuff doesn't fit in either. There's a corresponding effect called La Nina, and one of them, El Nino, it gets warmer than normal. La Nina gets colder than normal. These are Spanish words, of course. Both of these periodic factors could give correlations. Now, in other words, we could have the El Nino effect, we could have the sunspot cycle, we could have the 100-year thunderstorm cycle. All of these could be factors that are affecting the correlation. Right? They could affect both varves and tree rings in different parts of the earth. Many scientists are irrational in their reasoning. Here's their basic argument of many scientists. First premise, if there's a cause and effect relationship between two things, then there's a correlation between the two things. Well, that's axiomatic. That's a self-evident truth. That's true. We agree with that. There's a correlation between the two things. We agree there are many things that correlate that aren't linked by cause and effect. And this argument, they say, well, there's a correlation between the two things. And so they say, okay, well, what's wrong with claiming that? Well, you're framing the consequent. Now, let's go back up here. I'm going to highlight this. If there's a cause and effect with my mouse, the effect relationship between the two things, that's your antecedent. Antecedent. Antecedent, that's Latin for going before. And then that part that follows the word then is the consequent. There's a correlation between the two things. So you can, if you affirm the antecedent and then prove it, and there's a true relationship between them, then you've proven your consequent. But affirming the consequent is a logical fallacy. So this argument is invalid because it contains a logical fallacy of assuming the consequent. You affirm the consequent, and that proves nothing about the antecedent. All right? That's a logical fallacy. Take one course in logic, that's one of the first things you'll learn. And then they conclude there's a cause and effect relationship between the two things. Well, that doesn't prove a thing because their whole argument's logically flawed. Since the argument's logically invalid, the conclusion is not proven by the argument. We know from logic alone that it's not necessarily true. I've already illustrated it by saying, look, if there's a cause and effect relationship between the salaries of all occupation in the United States and the crime rate, if there's a cause and effect relationship, then there's a correlation between their salaries. And then I affirm there's a correlation, therefore there's cause and effect relationship. I've affirmed the consequent. And that doesn't prove anything. It's bad reasoning and it's bad ways to do science. Those who use barbs to date the Earth or to argue for an old Earth invariably assume the barbs are evidence of annual deposition, and they overlap the barbs. Now, to summarize the lesson, it'll be yours. Correlation is necessary for a cause and effect relationship to be present. All right, that's true. We agree with that. Correlation is not a sufficient condition. Now, necessary, it has to be there for there to be a relationship. If it's not there, there can't be a relationship, cause and effect relationship. That's what necessary means. Sufficient means if you have it, then that's true. Let me illustrate this. If an automobile engine is running, internal combustion engine is running, it has fuel. Fuel is necessary, but the fact that it has fuel in it doesn't prove it's going to run. So if you think about it, you say it's necessary to have fuel for an internal combustion engine to run, but the presence of fuel doesn't mean it's going to run. It might not have any spark plugs or maybe other factors that keep it running. All right? Arguments from barbs make two basic assumptions. Number one, that the barbs are annual or yearly deposits. And number two, that correlation proves cause and effect. Both of these are, the second one is a logical fallacy, and the first one is a logical fallacy of affirm. As the second one affirms the consequent, that's a logical fallacy. The first one begs the question, assumes what they're trying to prove. And so again, the atheists and their dating of the earth, and we're dealing primarily with evidence from the flood, and their dating of the earth as many tens of thousands of years old, or at least hundreds of thousands of years by barbs, is flawed. And of course, they eventually go back to So part of this dating, they go back to radiocarbon dating as well. Any questions or comments?